everybody, welcome back to my small garage machine shop. So I'm really excited about today's video. I have been eyeballing these coolant misters for a while. I finally pulled the trigger on one, and you guys have probably seen in the last couple of videos, well, actually all the videos, it's been in there. But I haven't had it that long, so I don't want to give you guys my opinion on it. We're going to run it through some tests today. I am going to look at the finish under a microscope. We're going to see, if we do get a better micro finish, if it's not visible with the naked eye. And then I'm going to do heavy cutting with and without coolant. And we're going to look at the inserts and see if, it extended the insert life. All right, so stick around. I'm going to get things set up, and I'll see you at the lathe. Okay, just really quick here before we get testing underway. You can see I added the snap-on thermal imager in here. I'm going to use that to look at the tool, as it's working, and we'll see how much heat is produced into the piece, into the insert, and hopefully get a good idea whether this mist coolant is actually working. And also, I wanted to just quickly go over some of the claims that are made by, these mist cooling systems. So 1,000 times more cooling than an equal volume of flood coolant, 2 to 3 times extended tool life, better finish, better chip evacuation, less mess than flood coolant, and people and environmentally friendly. So that part of it comes from Kool Mist. I'm using Kool Mist 78. So mixing it 4 ounces per gallon, or 32 to 1. Their recommended mix is 4 to 6 ounces. So I've been using it at 4. So that's what we're going to do today. We might even try to increase the mix a little bit and see if it changes anything, but I'm not positive on that part of it. All right, so without further hesitation, let's get things underway. I'll see you at the lathe. All right, guys. So in the chuck, I got a piece of 4140 chromoly. The part that I'm going to be machining here is 1 inch 47 thousandths. I'm going to do a finishing type pass at a slower RPM, so it's going to be 150 RPM. Feed rate is going to be 3 thousandths per revolution. I'm going to run the first inch with no coolant, and then we're going to do the second inch with coolant. And we're going to compare the finish we get. I'm going to take some thermal imaging shots so we can see, what kind of heat we're getting out of it. And we're also going to look at it under a microscope. All right, so the insert we're using is a WNMG 332. All right, we're coming up on the inch mark here, so I'm going to flip the coolant on. Okay, well, I think that's pretty clear. Let me blow the chips off this thing. I'll bring you guys in for a closer look. All right, so on the right side of your screen here, you can see that is the no coolant side, and then here is the coolant side. And I mean, guys, look, that is just, I mean, that's remarkable at 150 RPM. So, I mean, there's not a ton of heat being produced there. I did take thermal imaging shots, which I'm going to show you guys. But I mean, just, lubricating and that cooling, that little bit of cooling, it really makes a difference. I mean, that's really amazing. All right, so now what I think I'm going to do, I think we're going to go with a little bit of a deeper cut at a higher RPM, and we're going to see how we make out with that one. All right, so now we're going to take 50 thousandths off the piece. I move the RPM up to 200, and we're going to do the same drill. We're going to do first inch no coolant, and then I'm going to turn the coolant on, and we're going to compare the results. Okay, we're coming up on the inch again. I'm going to go ahead and flip the coolant on. Okay, let me get the chips blown off here. I'll get you guys in for a closer shot. Okay, guys, so on the right-hand side of the screen here, that's the no coolant side, and this is the coolant side here. So, really similar result to last time. You know, I think just definitely an improvement. You know, it ran much cooler. Like I say, I'll show you guys the thermal imaging shots also. All right, so next we're going to kind of crank things up another notch here. So give me a second, I'll get things set up. Okay, guys, so I turned the machine up to 225 RPM, so I added another 25 on, and this time we're going to take 75 thousandths off the piece. All right, so same drill as last time. All right, we're coming up on the inch here. I'm going to go ahead and flip the coolant on. right, guys, let me get the chips blown off here and I'll give you a closer look. All right, folks, so on the right-hand side, we have the no coolant, and on the left-hand side, we have the coolant, just like before. And I would say that, you know, every cut was definitely improved by the coolant. You know, I don't see any drawbacks to it at this point. You know, it doesn't make a mess. You don't need a special setup. It's portable, so it's, you know, you can move it from machine to machine if you have multiple lathes or multiple mills or whatever. You know, bandsaw, things like that. So it's versatile, and you know, there's cheaper versions of this one. This one's right around $100. So, like I said, I'm not exactly sure on that, but I'll get that posted up in the video for you guys. But I mean, you could buy these as cheap as, I think, $18 on Amazon. Now, do they work as well? I can't answer that one, but maybe that's something for a future video. You know, if you guys like this one, maybe we'll do one where we, you know, test the cheaper one versus more expensive one. You know, because if that's the case, I mean, it's really attainable by anybody. All right, so I think what we'll do next here, we will test the insert life. So we're going to basically take some heavy cuts and look at the insert with no coolant, and then we're going to do the same thing with, you know, and just see what kind of wear we get. We'll utilize the microscope to get a real close-up image of what we got going on. So, all right, let me get this set up, and I'll be back with you guys. All right, guys, so for the next part of this, it's going to be more of a roughing type of cut. I've increased the lathe RPM to 350. The feed I turned up to 5 thousandths per revolution. So before it was 3, so almost double. I'm going to be using a new insert, and we're going to do 3 passes at 50 thousandths, no coolant. And then I'm going to do the same thing, obviously, with coolant. And we're going to compare. We're going to look at the inserts under the microscope. We'll compare the thermal images. We'll compare finish. And then I would say, just as a little bonus, at the end here, I'm going to check the diameter of the piece after I make the 3 cuts with no coolant. And then I'll let it return to room temperature and take one more measurement at the end to see if, you know, if there's any expansion there. All right, so let me get the lathe set up, and I'll be right back with you guys. Okay, these are going to be the 3 passes, no coolant. Okay, so that wraps it up for the 3 no coolant passes. I'm going to take a quick measurement here off camera, and then what I'll do is let it cool to room temperature, and we'll take another measurement. All right, well, unfortunately, my camera died and I lost a little bit of footage there. I only cut this small area right here. So I'm just going to carry on with it from here. Only thing we're going to add in here is the mist coolant. Everything else is going to remain the same. All right? All right, guys, let me pull this out of the chuck. I'm going to take it over to the microscope, and we're going to take a look. Alright guys, so I got the thermal imager set up over the lathe here. Unfortunately, I cannot get the video to record out of the actual unit, so I have to kind of hold my camera here, and I apologize for that. But what we're going to try here, I'm going to run this at 65 thousandths off the piece, and we're going to just run it about halfway like we did before. I'm going to flip the coolant on, and we're going to kind of see what we get for temperatures there. Now, if you look on the right-hand side, you'll see 88 and 69 at the bottom. So 88 represents the hottest part of the picture, representing that yellowish color. And then 69 would be that dark blue color there at the bottom. So, as things change, obviously, those temperatures are going to go up and down. All right, so without hesitation, let's get rocking here. Okay, I'm going to go ahead and flip the coolant on. right, guys. Well, I think that was really cool. I enjoyed that a lot. I'll try to get this thing up and working maybe for the next video. Okay, well, I almost forgot to mention the measurements that I took after the roughing operation. So I did those 3 cuts, and then I took a measurement on the piece while it was still hot. And then I let it cool to room temperature. I took another measurement, and I compared those two, obviously. So what I got, no coolant, directly after cutting, I got 1 inch, 63 thousandths, 7 tenths. After it cooled to room temperature, which was 72 degrees at that time, 1 inch, 61 thousandths, 4 tenths. So that's a difference of 2 thousandths, 3 tenths. So that's pretty significant. And with coolant, we got 1 inch, 59 thousandths, 8 tenths. And then after it cooled, we got 1 inch, 59 thousandths, 6 tenths. So only 2 tenths difference. That really, really proves to me that, look, that coolant is doing its job, even in that little mist form. It's really improving things, not only finish, but temperature, keeping that extending that tool life, looking at those tools under the microscope and being able to see that, indefinitely, that it's doing its job. Okay, everybody, that's going to wrap things up for today. I really appreciate you guys tuning in. I severely underestimated how hard it would be to make these videos. I kind of always thought, watching YouTube, that you set the camera up and you just do what you normally do and you put it out and people go, oh, wow, this is great, But that's not the stuff I want to put out. I want to put out something that I would enjoy watching. And I'm trying my best to do that. I have never edited a video before in my life. I'm not good at talking in front of the camera. So there's many things I need to work on this end, but I hope I'm doing a good job. Anyway, guys, appreciate it as always. Like, comment, subscribe. I do appreciate it. And until next time, take care.